everyone. This is going to be an introduction to Autodesk Hydraflow Storm Sewers. Excuse me, I'm going to apologize in advance for my voice. My seasonal allergies are trying to hang in here, and I'm going to try to keep them at bay with a little bit of water from time to time. But again, this is an introduction to Autodesk Hydraflow Storm Sewers. We're going to try to hit the high points. I'm hoping to get through this and allow some time for questions. I'm Scott Craner, an applications expert in infrastructure solutions. There's a little information up there about me. I've been in civil engineering for a little over 30 years. I've been with ASI and Imaginet for 3 years in support training and consulting services. And this is just an outline of what we're going to try to cover here today. We're going to go through the setup in Civil 3D. That's the preferred workflow for using Hydraflow Storm Sewers to do the actual layout in Civil 3D, then set up your pipe networks and all the migration settings, export them out to an STM file, and then bring those into Storm Sewers. And then we're going to get into Storm Sewers, look at the interface, look at the settings, discuss some things about file management, look at some of the Storm Sewer elements, just so you're familiar with what's there, how they're represented, what's going on there in Storm Sewers. Look at entering the data, running computations, the results and reports, and then we're going to export the results back into Civil 3D and update the model. And again, hopefully we'll get through this fairly quickly and have plenty of time for questions. So without further ado, let's get into the software. Here we are in Civil 3D. This is Civil 3D 2020. I've got a model here that includes a surface with a fairly simple road with side ditches. In those ditches, I've got some drainage structures set up. They're drop curb inlets. I've got 2 rows of 3. Up here at the north, I've got a pair. Down here in the middle, I've got a pair on each side of the road. And then down here on the south end, I've got 2 more. They connect into the central inlets, run through a manhole, and outlet into this fairly large, convenient pond area where we're going to discharge. So that's what we've got in Civil 3D as a model. I want to go to settings here and discuss a little bit about the prerequisites for getting this system into Storm Sewers. First thing you want to do, we're using this Storm Sewer parts list. You want to make sure that the parts list, and I'm going to open it up so you can see it. You want this parts list to have all the parts you need, not just for this system that you've built, but for any design changes you make in Hydraflow, so that when it comes back in, you've got parts so that when parts are switched out. So you can see that I've expanded this. I'm going to be using concrete pipe in this model. I could use any type of pipe I want, but notice I've got plenty of sizes here so that when I come back in, if some of the sizes are upsized, it's going to be able to switch them out. I've got corrugated HDPE pipe down here, which I'm not going to use. And just to show you conversely, there's only 1 size in here. If I was going to use this for anything, I would have to put more sizes in here. Or when it comes back in from Hydraflow, it's not going to have enough types to switch things out. I'm switching to the Structures tab. And I just want to show you first, this isn't a huge parts list. I'm sticking with what I'm actually using. I'm going to use a concrete rectangular head wall. And I've got quite a few sizes in here to make sure that the size comes back. I will let you know that I find frequently that when you're bringing things back from Hydraflow Storm Sewers, the head walls that get calculated aren't exactly the right size in Civil 3D. And so what they'll do when you have a list like this, and I think it happens in this case too, it will, if the exact size isn't here, when it imports, it will just go to the next size up, which works out just fine. Normally, your parts list is going to contain all of the parts that you actually will be using. And I think that's just something I find out of storm sewers that it calculates a head wall, and it's not going to be exact. That's one of the things I find coming back in. So it's just going to go to the next size up. This eccentric cylindrical structure, this is what I'm using for my manhole. And again, I've got quite a few of them in here to make sure that if that has to be upsized, that would be available. A null structure, which you always have to have. And then these are going to be my catch basins. And I've got all of these different sizes to represent the whatever could be changed and brought back in. So you've got to have all of those parts available. Otherwise, you end up with getting error messages that the parts aren't available or it can't properly select a size for you. If there's a size that's not quite right, it does tend to go to the next size up. So that usually works out well. So that's the first element here. Once you've got your parts list all set up, the next thing you want to consider is that the pipe network. Let me select this. Go to the network. You want to make sure that the pipe network is using that same parts list. If you've got a different parts list called out here than the one in the drawing, well, that's not going to work to begin with. But this parts list, the parts list in here, all have to match the migration settings. And that's what I'm going to go to next. So this has to be set up in your network. And then we're going to go to migration settings. There are two different levels of migration settings. The one I'm going to be working with is this first one at the object level, right at pipe network. If I right click and select edit feature settings, in these feature settings, I have the storm sewer migration defaults. I'm going to get back to this here in a second. I'm going to show you the next level. Down here at the command level, if I open up the commands, there is a command in edit and SSA, storm and sanitary analysis, and edit and storm sewers. So I'm going to click storm sewers here, and it looks identical to the one up at the object level. But these can be set at these two different levels. So you could actually have one set of settings down here for storm sewers and another set for SSA if you wanted to. I can't off the top of my head think of why you would want to do that, but you've got that ability if you needed to. For instance, you were doing different types of work with the two different software packages. I'm going to close this back up. We're going to be working at the object level, and we're going to keep it all the same. When you can, that's what I recommend. Let's discuss these migration defaults just a little bit. First, we've already discussed this, or the second item actually, parts list used for migration, storm sewer. That needs to match what's in your pipe network, and it needs to be in your drawing, and it needs to be properly set up. So that's the first thing that needs to be right. Up here at the very top, part matching defaults. I'm going to select and then select the ellipsis to open that up. This is an element that a lot of people either aren't aware of or forget. What you're doing here is you're setting up on the import. This is importing from storm sewers to Civil 3D for every possible type of object in storm sewers. You're matching it with a part type in Civil 3D. So for instance, for my circular manhole, I'm matching it up with my eccentric cylindrical structure. The reason I've selected that is this is out of the box. This is what comes in the standard template, so I didn't change it just to keep it something that you can open your template up and see this too, just out of the box. You might want to select something else here. That's perfectly okay, but I just left this set the way it was, and that's what I'm using for this example. Down here for head wall, again, this is out of the box, concrete rectangular head wall. So I'm using this to represent my head wall. And for my drop curb rectangular structure, slab top, rectangular frame, again, this is out of the box. So you need to make sure that these are set up. If you don't like the Civil 3D part that's matched with the storm sewer part, that's perfectly fine. You can switch them out to either something else in the parts list, or you can create your custom parts to be what you want them to be and set those all up in here. But you do need to make sure that the import and export match, and let me show you that here. On the export tab, this is when you're going out from Civil 3D to storm sewers. These are all of the different families of parts, and they're linked to all of the different parts in storm sewers. One thing I wanted to show you this about, right off the top is notice that there are a lot more Civil 3D parts than there are storm sewer parts. So everything doesn't match up one-to-one. And there's a point to knowing that. I'm using concrete pipe, and when I'm going from Civil 3D to storm sewers, it's going to become a circular pipe. But if I had multiple types of pipe in my model, they would all be coming in as circular pipe. In storm sewers, the only way you distinguish the different pipe is by changing that Manning's N value for the pipe. Storm sewers doesn't look at that as a visual structure or a visual entity like it is in Civil 3D, where you're laying it out and you want to have a visual representation of it. Storm sewers is only interested in the hydraulics and hydrology. So it views a pipe as simply a conduit with certain properties that get punched into hydraulic calculations. So that Manning's N value is really the only thing that's critical. But this is important because if you've got multiple types of pipes in your drawing and you kick them out for analysis, and then when you kick them back in, if they're going to all come in as one type, the best way to handle it, the most efficient way to handle that, is just select one pipe to kick out and come back. It's going to be your predominant pipe, and then when your model is changed and the sizes and inverts are what you want, that's the time to go back through and just change the pipe type in Civil 3D so that the labels and everything show up the way you want visually. If you try to take that all into storm sewers and you have it all differentiated by type, when it comes back, it's going to change back to just one type anyway, so it's just not worth the effort. Notice also that head walls. There are various types of head walls, but in storm sewers, there's only one head wall. So similarly, the best thing to do is select the head wall that you're going to use the most often, and then when you bring it back in, if you need to adjust that type of head wall for the circumstance, adjust it once you're in Civil 3D. So this is really important. The import and export settings, they've got to be set to what you're using. If you're not going to be using something, you don't have to set it up, but they have to be correct both ways. If you have something exporting out of Civil 3D into storm sewers one way and then coming back in a different way, it's going to be very confusing. So make sure this is all set up. So we've got the part matching defaults, and it's pretty clear we've got to have the parts list aligned up. The next element here that people have question about are this allow part family swapping and then the use imported part ID for part family. The help on this explains it, and if you already understood it, you probably would even understand the explanation, but a lot of people have problems with it. So let me try to simplify that for you. With the part family swapping, what that does, if you set it to yes, then if you decide that you want to change from one part family to another, for instance, you want to change from say a curb inlet to a combination inlet, that's a different part family. It should be set up differently, and you could do that when you're in storm sewers. You might want to do that because hydraulically, you're looking at your spread and depth calcs on your roadway, and you need just more water to go in that inlet, and you're looking at cost and meeting criteria. So if you want that to change, to come back in and switch that out, you've got to set this to yes. If you don't, there's a very limited list of things that can change when you're coming back in. And that list is, and let me read that off to you so I get it right. For the pipe, only the size, Manning's N, slope, length, and location can change. And if this is set to no, for a structure, only the length, width, and location information can change. So if this is set to no, you're very limited in what can change when you're bringing parts back in. And basically what you're eliminating when you say no here is you can't switch from one part family to another. Now this other setting down here, use imported part ID for part family, this works with this part family swapping. If this is set to no, then this doesn't matter. If this is set to yes, then this tells you what part ID you're going to use. If this is set to yes, you're going to use the imported part ID. Well, what does that mean? That imported part ID, if it's set to yes, is the storm part. If it's set to no, then instead of using the part ID in the storm file, it's going to come back up here to the migration setting, the Civil 3D migration setting, and use that part. So standard setup is to have part swapping yes and imported part ID no, but you can change this. Just understand what you're doing. With these properly set up, you should be able to migrate your parts, your pipe network from Civil 3D into Storm Sewers and then back again, and everything should line up for you. Okay. So here we are in plan. I'm just going to go over and show you the same system in profile. So here we are. This is set up on the roadway profile. And so some of the elements are stacked here. I tried to separate the labeling so you can see what's here. The biggest thing to point out here is I've laid everything in according to basic rules. Everything's sloping from these outer drop inlets into the center inlets here in the middle, and then running down and finally down to this head wall. Everything is set so that the pipes are all 12 inches. Everything is very basic. Nothing has been sized, no hydraulic analysis done. So this is the model we're going to be looking at. And I go to the Analyze tab, and I want to take this out to Storm Sewers. There are a couple ways to get into Storm Sewers, and I'm going to show you, if I just want to launch Storm Sewers, you can launch it down here by pulling down this design on the Analyze tab and the Design panel. I can just pull down and you get other options here. I'm going to launch Storm Sewers just so you can see that. And let me drag that on screen for you. Now that I've got this open, I can open a file and show you all kinds of stuff here. And I'll do that here in a few minutes. Let me show you the other option. With this model here, I can just come up here into the Design panel of the Analyze tab and select Edit in Storm Sewers. It's going to bring up the pipe network if you have one in here. If you don't have one, it'll give you a warning saying you don't have anything to export. If you have multiple networks, you could come in here and select which ones you want to export, or you could export multiple ones out. I'm going to click OK. It's going to ask me where I want to save this. And you can see I've already saved this out to my desktop. That's where I'm going to save it. And I'm going to save over it. I'm going to bring it in so you can kind of see this is just a model in Storm Sewers. Now, before we get into running some calculations, I do want to show you around a little bit. You've got some pretty standard pull-down menus up here for handling files, for editing, for computing. This is your different computational methods, and I'll get into that later. For IDF curves, if you wanted the viewer load them or create new ones, and I'll get into that a little later. And then you've got options. If you want to change the color, the size of your labels, which labels you're showing. I tend to like to have all the labels on. It helps me navigate around here, but if you wanted to turn these on and off, you can. I like to have it usually gives me an auto scale. That's pretty handy. You might want to change this in certain circumstances, but auto usually works good for me. But this just kind of gives you a way of coming in and changing the way things look. There are sound effects here. You could shut them off if they bother you. This alternating grid, let me get out of here and show you. And I'll get down to these tabs later, but in some of these views, you have spreadsheet kind of layout, and the alternating colors really does make that a lot easier to read, so I leave that on. So this is the kind of pull downs, and then you've got a typical help where you can pull out and get information about the software, and then you could go to the actual content and look through anything if you wanted to pull up the help information on it. So this is pretty standard up here. You've got toolbars at the top. These, some of them are redundant, some of them are available up here in the pull downs, but this opens files, this saves files, this kicks out stuff to reports. So once you've done your computations, this is a special one that it's your design codes, and I'm going to come back to this and walk you through this here in a few minutes. This is similar to the IDF curves, but it's going to actually load what you've got. Let me drag that on screen here. This is the one that's loaded. If you want to see what it is or go in and take a look at this, You can just select it right here in the toolbar. I'm going to exit out of that. Some of these other tools are for editing, inserting, and deleting elements here once they're selected. This run is for running your computations. It's the same thing as coming up here and selecting compute and then selecting up here, but this gives you a dialog box to fill things out. Once you've done with your computations and you want to plot either the plan or your profiles, you can plot from here, or from the Profiles tab, you can bring up your profiles, adjust them, and plot from them. You can also send things out as an XML file. When we get to files, you can bring things in from XML file too, and at one time that was the preferred way of doing things. But I'm showing you the newer workflow and the newer version where you go directly in and out from Civil 3D. And you can also export to a DXF. That's kind of handy if you want to take some of these plots and put it in a format that then you could drop into a drawing and submit. So this toolbar is different from this toolbar. This data toolbar has information related to this plan view. If you want to drop a manhole or an inlet in, those elements are right here. You can select them and you can manually input them. It's not the preferred workflow, and if we have time, I'll show you. There is kind of a process to this that you've got to get used to. It's very different than Civil 3D, but you can actually construct your systems in here. You've got information here when you select one of these. You can see that the angle, and that's the angle from the last line, and then the distance, the length is here. You can edit these here. You can lock them. So when you're in here, if you wanted to manually adjust this, that's not the preferred workflow. It's better to do this in Civil 3D, but you have the ability to do it in here. And if you select another one, you can see it changes to the angle and the distance to each line. Something to keep in mind when you're looking at these elements, each one of these elements that you lay out in here, except for the first one consists of an outfall, a pipe, and a structure. All the others are a pipe and a structure. That's one entity. And when we get into the data input, I'll show you how that looks in this data tab here. But let's go ahead and go along and talk about some of these other pieces of tools up here. This one allows you to put in text if you want. So if I want to add text, I can add it right there. And then this one allows me to edit the text, change the font, the size, things like that. Now, if I don't want to do that, I can just escape. If I wanted to keep that text, oh man, that's probably what I didn't want to do, move that. But if I wanted to keep that text, there, I would have to come down here and click OK, but I'm going to cancel it. Let's see here. This is the plan view. You can see our models laid out here. Down here, you see the name of the STM file. You see the number of lines, and you see a northing and easting. When I'm moving my cursor around, that's the location of my cursor. We've also got zoom tools over here. You can zoom in, zoom out, zoom to extents. If I had a DXF background in here and I can pull one in, I'm going to import one right now just so you see what that looks like. Yeah, drainage areas should look okay. And so I've imported drainage areas. Once I have a background in here, I can use this, which zooms to the extents of the background. So that kind of zooms out to that. So you can see the full background. And that's basically everything in plan view, except for this data. This data dialog box, when I click it, this is how you go through and you start inputting information in here. Everything's been laid out in Civil 3D, but when you come in here, pipe by pipe and junction by junction, there's information you'll fill out in here to get your rational equation calculations done for your time of concentration and your Q values. And we'll go through this in a few minutes too. But before we do, let me go ahead and just close that and show you, other than plan, we've got a pipes tab, all the information in your pipes, and you can input information here too, and an inlets tab, all the information on your inlets. And this is also a screen you can use for input. And then you've got a results tab. The results that show up depend on, this is the summary results. This is a reporting tab. And so if I pick the DOT tab, it shows me a different kind of report. Inlet report, Florida DOT, calculations, cost, shows me my cost information. And then if I click on the My Report, that's everything available. And if I wanted to create a report of my own, I could simply click the ellipses. It brings me into this My Report. And this allows me to, I could clear it out by selecting this. I could change where I'm saving it, or I could go get a report and pull it in. I can save it here. I can get help here. I can change the name or create a name here. And then all of these columns here, this is, in this My Report, this is every bit of information that's there. I could clear it out and start over, or else I could start just eliminating what I don't want. This button down here eliminates a column. This button adds a column. And when you're in a column, you can always pull down and select from any of the information available to arrange it any way you want. It's a pretty simple system, pretty straightforward, very powerful. If you know what you want to do to set up a report, you can set it up any way you want. You can exit out of that. And at this point, I'm going to go back to the plan, and I'm going to go back to the data. And I'm going to just take you through the process of putting data in here. First quirk about this is, to start, you need to hit OK. When you do, these arrows turn from gray to blue and allows you to move through the different alignments here, your network. You can go all the way to one end or all the way to the other end, or you could just step through it. Start at the beginning and look at how things are laid out. If you look at all the labels here, this shows me that the outfall is the downstream end. It's pipe number 3. And then if I go to the junction, that's a manhole. So we're looking at this pipe right here. So looking at this, I know that I don't have any flows here. It's a manhole. I'm not going to have any water coming here. There's no area. There's no known Qs, drainage area, though I want to add no coefficients, no time of concentration calcs. But all of this information is available here for you to edit. There's also alignment information here too. I don't recommend editing that here. That's part of what we recommend you do in Civil 3D. You can change the length, change the deflection angle. You can change the northing and easting. But again, we don't recommend changing that here. That's better done in Civil 3D, but you do have access to it. Over here is information about basically the lay of everything. The invert elevation down, the slope, basically the layout of the pipe. You can come in and change this here. It is better to let it design it. And these baseline stations, they're automatically done when it comes in here. And again, we don't recommend you change that here. So let's go ahead and move to the next upstream and go ahead and start putting in some of the information I do recommend you put in. So in this case, I have done some analysis of my drainage areas, and I'm going to put things in here using weighted runoff coefficients. Before I start doing that, I'm going to exit this and show you where those are saved and just take you a little through design codes. Design codes are your defaults that you set up. You've got defaults for your pipe. You can have a minimum pipe size, and you can change that here, a maximum pipe size, design velocity, minimum slope, maximum slope, and minimum cover. I'm going to add this zeroed out falls because that's a change I normally make. You can change your default in value in your pipes. Now these are the defaults, so you can always change them in the dialog box I just left and we'll be getting back into. But this is where you set the defaults to minimize all of your data entry. If there are certain odd sizes of pipes you want to omit, you can put a check mark here. I usually omit all three of these, but it just depends on what area I'm working. You can also adjust whether you're matching crowns or inverts of your pipe. I typically match crowns when a designer lets me match crowns. It's better hydraulically, but some designers like to match inverts. You can add a match line drop. This drop that you put in here is only for pipes of the same size. So some designers like to see when pipes are of the same size, a drop across structures. You can put that value in here. It's not a good idea to have smaller downstream pipes, but if for some reason you have to work on a network where that's necessary, you could allow that right here. That's the pipes tab. Let's go to the inlets tab. The inlets tab is basically all of the default information for your curbs, for your inlets. The curb information, the inlet length, throat height, the type of opening. And I'm going to set that to horizontal here. That opening type can be, as you can see, it's horizontal or inclined. If you're familiar with curb inlets, that's the two types of opening that are in HEC 22 and most commonly produced by any manufacturers I've seen. The straight ones are just a straight opening that's horizontal. The inclined ones actually are the actual opening from the pavement into the inlet is inclined on an angle. I'm going to leave this horizontal because this is a typical curb inlet in a ditch, which are typically horizontal. The clear area, this is grate information, clear area, width and length of the grate. These are the defaults. The gutter, road cross slope, width, local depression, end value of that gutter, structure, shape, and diameter, or if it's not round, then dimensions, length and width. This grate design depth, this is used when you've got an inlet in sag, and so that depth is used to calculate the orifice equation for calculating the capacity of that inlet in a sag condition. This inlet end value is the default end value for that calculation. And then here's your composite runoff coefficients that I was mentioning. I'm not going to change these. The 0.9, which equates to pavement, 0.5, 0.2, they're kind of, I'm not going to say standard values, but kind of values that I see a lot when you're weighting the average of an area for runoff calculations for the rational equation. But it depends on what surfaces, what kind of what your site conditions are like. You might want to change these. You can change these here. Once you've changed them here, they kick up each time in that dialog that we just left, and we're going to go back to. I'm going to go ahead and click the Calculations tab and just take you through this pretty quickly. These, again, are your defaults for calculations. This minimum starting depth, these are the main ways you determine the water level at the outflow. It could be the crown, the normal water elevation, the critical elevation, or this DC plus D over 2 that's halfway between critical and the inside diameter of the crown, so it's kind of between critical and crown here. That's normally what I've seen around and used around here, but it can be, those are the four main types, so you can set it to whatever you want. This correct EGL discrepancies, I'm still trying to get more information on how this is calculated, but the correct EGL discrepancies, as I've tested in the software, looks to me like what it does is when you've got water coming into an inlet or a structure from multiple sources, and that combination of cues coming in create a second hydraulic jump at that inlet, it goes up. And I've got an example I can show you that where I kind of demonstrated that to myself, how it works. So I usually check this, but I know there are people that have asked how this is being calculated, and I'm looking into that to try to see exactly how that's calculated. It should be based on something in HEC 22, and I'm trying to see what that is. This check for inlet control is basically checking for whether or not the water in a pipe can be controlled by the friction in the pipe or the actual limitations of that actual inlet. So if you want to check for that, you can click this. If you do, this HDS 5 is it's really a publication for culverts, and so if you're looking at most storm sewer systems, this is probably not what you want to select unless you don't have other openings, because a culvert's kind of a closed system except for at each end, and that's how this publication was developed. The standard orifice equation is what most people use here if you want to check for inlet control. The flow options: accumulate known Qs. This is if you want to put Qs in that dialog box we'll get to here in a few minutes. If you put them in, it will accumulate them. This use inlet captured flows in the system. This is if you want to, instead of taking all the water, most of the time when you're sizing pipes, you want to just assume all the water goes into the pipes to make sure that you're being conservative about sizing your pipes. If you click this, it's only going to look at the capacity of the inlet and limit how much water flows in that inlet based on its capacity. So most people leave this unchecked. It's an iterative process to design things, so you might go through and analyze your inlets and then analyze your pipes and change some of these settings to make sure that you're being conservative in how you run your calculations. But that's what this is doing. It's limiting the flow in the pipes to what can actually come through or what it calculates coming in through the inlets. And the suppress pipe travel time, again, I don't usually check this. I'm not sure. It's nice to have this option, but I'm having a hard time seeing when I would do this. The pipe travel time is an important part of the calculations, and so I would want to consider it. I guess if you didn't consider it, it would be somewhat more conservative, but it would, I think, in most cases, kind of be inaccurate. So I leave this unchecked. You can add a minimum TC for calculating intensity. Put that in here, and that again is a default. Junction loss coefficients. The junction losses are going to be calculated, but the coefficients can be calculated automatically, and there's a little explanation in the user's manual about the automatic calculations. You can enter them manually if you want to calculate them manually, or you can use the composite calculation. I'm looking into the exact calculations for this automatic method. I've requested that information from Autodesk. I've requested information on the composite as well, and I got information on that. That is based on HEC 22, the composite method in addition to the second edition, not the third edition. So this is based on HEC 22 second edition, this composite method. If you choose this, if you want to look at calculations that are from the third edition, FHWA did some considerable research into that between those editions and came up with some additional rigorous iterative calculations. Those are available inside Civil 3D in the calculations. Let me pull up Civil 3D here and show you that in this Analyze Gravity Network, that's based on the third edition, which is the most recent edition. So, but in Hydraflow, this is based on the second edition. And this allows supercritical depth. Normally you don't. Normally in most of the calculations I've done, it's assumed that this is going to not have supercritical flow, but the way the calculations are done, where they're balancing the energy, calculating the pipes, and it's an iterative process, they can come back and actually calculate supercritical flow and put hydraulic jumps in the pipes where they're calculated. So if you want to allow for that, or if there's a need to consider that, that can be checked right here. So that's your design codes. I'm going to click OK to accept the changes. So once those are set, and we know which IDF curve we're using, and for this calculation, we're using their sample. Let's go make sure all of the data is in here. I'm not going to make you watch me fill it all out as I've gone through here. Let me click OK. I'm going to show you how I'm going to fill out this box with the composite runoff coefficients and the data I have here. And this is going to be, I'm putting in areas that I've broken this down into the areas that should have a 0.9, 0.5, and 0.2. And I grabbed that information from some measurements I took in Civil 3D. So this is 0.14. And when you put in those, it gives you the total area down here, which you can check against my value. 0.65 is correct. And then it does a weighted average of that coefficient for your rational equation. If you're good with that, you click OK, and it comes down here. Now it wants to figure out what time of concentration you're going to use. For this, I'm going to use the FAA calculation method. Once I select that, this box becomes available. I pull that up, and again, I took some measurements in Civil 3D, and in this drainage area, I've got 277.19 and a slope of 0.22. And we've got the weighted runoff coefficient. It was calculated up here. Now I'm going to compute the time of concentration. And everything is populated here, and I exit. Now, here's the bit that people don't usually catch about inputting data here, and why I'm going to the trouble of showing you this. If you just move out of this, see how these arrows are blue? This data hasn't been accepted. So this is just a quirk of this dialog box where you've got to come over here to this column, even though I'm not changing anything here. Once I click in this column, these turn gray. And then I click OK, and they turn blue again, and this information is accepted. If I wouldn't do that, when I moved on to the next or to the junction, it wouldn't be there. So, and you know what? None of this is right, because I apologize for that. I am putting all of my information in this manhole. So let me take that all out and move that information over. Yeah, should I? There we go. There. Let's move to the next line. So I'm in this line here, and I've got a manhole, so I need to move to the next line before I add that same information. Sorry about that. Okay. Exit, select the other column, click OK. So this data is stuck. I'll do that one more time so you can see it, especially since I put it in the wrong spot the first time. So I'm going to go ahead and click to this next. Oh, first I'm going to go to this inlet and junction and put in the road cross slope that I'm going to need here, and that's 0.02. And again, you want to make sure that you select over here Make sure the arrows are gray, and then click OK to make sure that's taken. So now that that's there, I could go ahead and move up to the next one, and that is pipe 7. That's this pipe right here. And I'm going to go ahead and enter these the same way, and then after that, I'm going to assume you've got the hang of it, and I'm going to just pull in my file where I've done all this, so you don't have to watch me do this. So here I've entered the acreages for the different types of coefficients. My total is 0.46, that's correct. I click OK. Now I select FAA, because that's the method I'm using, and enter the FAA method information, and that is length, and slope, average slope. And then once that's entered, my runoff coefficient, which is calculated up here, is there. It's weighted. I compute it. It's kicked in down here. I exit. Make sure that I select over here and click OK. And then go to the Junction tab. Make sure the arrows are gray and click OK. So all that's taken. Okay. So I don't want to have you watch me put all this information in. If there aren't any questions about this, and that's pretty clear. I think the only thing I want to show you is there is another way of putting information in here. So let me click OK and show you that. If I wanted to put in information not using FAA, if I wanted to use TR55, I could do that. It opens up another box. If you're familiar with TR55, you can see that it gives you a chance to enter the different types of flow information. It gives you a chance to do different weighted values. So if you had different soil groups and different types of coverage, you could put those down for your sheet flow area, your shallow concentrated flow, and your channel flow. So if you're familiar with the TR55 method, this is kind of a condensed version of it. If you try to click and look at help, it gives you some information there. Yeah, that's the same help there. But it's kind of truncated. There's not a lot of information on this. So I recommend that if you're going to use this method, that you get a copy of the latest version of TR55, where it goes through all of this in depth to come up with all your different values and your soil information for filling this method out. And people who typically use this usually do have a copy of that, but I wanted to make sure you see it's available. It's just not quite as in depth as you'll see in TR55's manual. So that's another method you'd have here. Let me go ahead and close that. And let me go ahead and close this. I'm not going to save it. I'm going to go ahead and open my version that I've already got done here. And get on with analysis. All right. I'm going to open up data. This is the same system. The only difference here, if I pull in the data, all that data that I was entering that you would have to watch, I've already entered that information here. It's been entered. Another way of looking at this information is if I go to pipes, you can see that all of my runoff coefficients, drainage areas, the TC and method for TC, all of that's been entered here. I got all my inlets, all of the road cross slopes have been entered. They're all in SAG, so it's fairly simple calculations. There's not a, I don't have, since these are drop curbs, they're all going to be designed in SAG. And so I can go to my results. You can see that when I go to results, it says compute. That's because I haven't run analysis on this yet. So that's the next thing I want to show you. I want to go ahead and click the, let me go back to plan so you can see the plan as I do that. But I'm going to run analysis. I could also come up here and select it up here. I typically do it here. It brings up a dialog box. This gives me a chance to check, you know, how I'm going to put the information here. I could use known queues, but in this case, I'm using I'm going to be using the rational equation. I'm going to do it to a 50-year. I'm going to use this interactive feature, and I'm going to show you what that is when I kick it up here in a few minutes. There are different methods of analysis. They give you a brief description here, but I'll cover that real quickly. The analysis with design, this basically is if you want to come in here and do some iterations and see, you know, where you are. This computes the system, design sizes, inverts. If you want to reset the sizes and invert elevations, you can check down here. Enhanced does essentially the same thing, only if you really want an accurate, the way this balances energy is an iterative process, and in the end, sometimes you end up with you calculate times of concentration, you make some assumptions about velocities, and those TCs are not exactly accurate at the end. This runs those in 3 iterations, and it balances the TC with the HGL, running 3 iterations to get them very close to each other, and makes for a little more accurate balancing of the energy. Full design is basically the same as analysis with design, but it's going to reset everything. So if you select this and select these, it's essentially the same thing. But by doing this, it allows you to just reset the sizes or just reset the invert elevation. So it gives you a little more granular control of that. So full design and capacity only. Capacity only is if you had an existing system and you just wanted to see what it can handle. So you put all the information in there and you just run through it and try to get an idea of what kind of capacity it has. That's what that's for. So it gives you a nice little description here. In this case, I'm going to run analysis with design, and I'm going to check both of these. And down here, I'm just going to check in and make sure that I'm using this DC plus D over 2 as my starting elevation for my tailwater. Like I said before, I'm using the interactive feature. So when I click OK, I'm going to get an error message telling me line 1 has no flow. Well, it has no flow correctly because it's a manhole. That's OK. And then it brings up my interactive feature here. And up here, you've got information about this line. You've got the Q, invert elevations, depth, HGL, velocity, and cover that's calculated from the analysis I just did. And then you've got a graphical representation, and I can turn on or off my EGL, which is hard to see. It's right down here. I've got it turned on. So my HGL is the solid, and my EGL is dashed. This is the ground surface. And you can tell it's upsized my 12-inch pipes to 18-inch. And this is the outfall, my first line. If I want to adjust anything, I do that down here. This gives me a spin button is what they call it. And when I'm on the pipe size, it doesn't matter, because if I click these buttons, it's going to take it up to the next available pipe size. But if I'm selecting, and with barrels, it's the same thing. But if I'm selecting elevations or something else, if I want to select the downstream elevation or the upstream elevation, or move the whole pipe up altogether a certain increment, I can set this to whatever value I want it to be to move it that amount every time I click this button. So it gives me control over how much it moves every time I click this button. And you can come in here and adjust things. You can adjust the pipe size, number of barrels, the elevations that I've indicated, the rim elevations. You can add cues right here. If you're set on one of these locations and you wanted to match the invert or match the crowns, you could do that here. If you wanted to adjust it to the minimum cover, you could do that here. Once you've selected one of these, if you wanted to move those changes all the way upstream or all the way downstream, you could select these buttons here. If you wanted to lock and invert, select the lock button. And again, these are the adjustment arrows. If you want to move up and down the system, one step at a time, you can move down, but we're at the very end. So if I step up, I just step up one run at a time. But if I want to go completely up to the end or down to the other end, you can do that here. If I want to undo something, I can undo it here if I've made a change. If I want to finish it, it will take all these changes and be done with it. If I want to cancel them, it will cancel it. So nothing's been applied yet. You're still looking at it in interactive. I want to show you what these buttons do. In this case, you're going to see this is the profile. And if I want to look at the inlet section, it's a little, it takes a little while to get there. It shows you a little about how the water is going to spread and the spread and depth information on that inlet. If you want to look at the plan, you can see where you are and which section you're looking at, what inlet you're looking at. So you can float through here and know exactly where you are by changing these. If you want to change the zoom, you can zoom in, zoom out, or zoom extents here. Let's go back to profile. If I wanted to change a design code parameter, I could pull up the design codes and I could move to the right tab and change whatever I wanted to change and apply it right here. Let's see. We've already talked about this. If I want to print, I can print from here. So this allows you to come in and fine-tune your design as you're moving through it. Once you're happy with the design, if you want to see if there's anything I want to change here. I think I'm going to take it as is, and I'm going to click Finish. It gives you that little audible message. And now I can look at the results in any format I want, or I can create my own format. If I want to plot any of this out, I can plot. And I can choose what I'm going to plot. I can, again, it takes a little time. I can move through the plan using these buttons. So I can plot out the information that pertains to the profile, the inlet section, or the plan view. And I can change my zoom here, and I can send those out to be printed. If I want to take a look at the profiles overall, I hit the profile, and I can here it defaults to the first pipe run. I'm going to go ahead and drag it all the way back to, let's see, update it. So that's showing you a section of the pipe. It goes from the outflow to the, and you could select whichever ones you wanted to look at. So from one pipe run to whatever pipe run. So I'm looking at a portion of this. If I want to adjust any of the text, turn on or off, stationing, grid, EGL, HGL, adjust text size, labels, junction labels. So you can turn this off if I want to change the height or width of this. I can adjust that here. So, and again, you can export this or print it. So this gives you a lot of control over kicking this information out the way you want. Let me close that up real quick. So that's plotting and profile. If I want to send this out in an XML, it's the typical XML in and out format that probably most people are familiar with, where you enter a name and basically save this out as an XML file, and then you can give it to somebody who doesn't have Civil 3D. It's a fairly universal file format. if you wanted to DXF this as a pipe layout, you could kick that out to a DXF file, and it's just going to ask you where to save it. So you could save this out to a DXF file, and somebody else could bring it in and put it on a drawing, or you could put it in and use it for your drawing. Let me close that. So it gives you a pretty good idea of what you can do to kick this out. Now what I'm going to do with this is, since I've run my calculations, I'm going to go ahead and save this. And I've saved it to the same file name. I could have changed the file name if I wanted to select Save As, but it's saved as the same name. Now what I'm going to do, I'm going to go ahead and close this, and I'm going to go ahead and reinsert this information and update my model. And it's not a big change. I think the biggest pipe change was an 18-inch, but if you notice, all these pipes are 12-inch. So I'm going to insert to the Insert tab, Storm Sewers. And I saved that where I got it. I should have put it here, but I'm going to go back to where I got that. That's going to be here. That's what I saved it to. Yeah, that's the right time. I'm going to open that. It's going to ask me, update the existing pipe network. Let me move this out of the way. I'm going to say yes. It's going to give me a warning here, and I anticipated this, because on head walls it typically does that, because you don't usually have the exact size they said. Yeah. So basically what this is saying is the structural outfall was not matched exactly. The closest larger matching size was used. I'm okay with that, so I'm going to clear all events and close this. And then as I get in here, you can see that the layout of these has been changed and the pipe sizes have been changed. So you can see that we've got 15-inch pipe here, and we've got 18-inch pipe here, and 18-inch pipe right here. Move that down so you can see it. So it's updated my design and imported it back into Civil 3D and updated the model. I think that's about all I wanted to show. I'm ready to take some questions. You have any questions?
Yes, we do, Scott. It is the top of the hour. We will be answering the questions also in blog form, and we'll send out a recording. So if any of you do need to jump off. One question that we had is, if we change any physical data, will it automatically update in Civil 3D?
It updates the way I just showed it. So if you do change data, it depends on the data you change in your settings. But if what you're changing is pipe sizes and invert elevations and things like that, and your settings are set up right, just like you saw, it's going to change that. If you decided to change the inlet type or a manhole type, and your settings are set up to allow part family swapping, that also could change as long as it's properly mapped to bring it back into Civil 3D into the right element, and as long as you've got those sizes in your parts list. Yes.
Did you export the drainage areas from CAD using the watershed tools?
No, I didn't. What I did is I developed those drainage areas. My surface was very, very flat, and the tool for catchments in Civil 3D doesn't do flat real well. And that was an enormous, this surface is very, very flat. So what I did do is I used the water drop command to develop those and use polylines. And then I took those polylines and created catchments from that. And then I just pulled information out from that and then plugged it in manually. There's not a link to take catchment information into storm sewers. The catchment information doesn't go directly in. That's got to be plugged in that dialog box where I plug the information in.
Okay. Can you do your hydraulic calculations from scratch and then import it into Civil 3D via Land XML?
I would think you can, but I'm trying to figure out exactly how he's talking. I mean, if you're doing your calculations, what form would they be coming in? If you did your calculations by hand, wouldn't you just update the sizes and inverts in Civil 3D? I guess I'm not following that question. I mean, you could do them by hand, and you could update using the interactive tool. You could update the file in Hydraflow, but then I'm not sure if you were going to do them by hand, it's worth stepping out of Civil 3D. As a matter of fact, there are some tools within Civil 3D. Analyze the Analyze Gravity Network, which is it's a little limited, but it's a good tool for doing some calculations within Civil 3D. And I believe that Randy did a piece on that not too long ago that showed you how that could be very useful. So I'm not really sure what form he would want those calculations to be in an XML file. To me, the XML file should contain the changed pipe, invert, and sizes, and I don't know why to take it out.
We'll take one more question. Does the TC automatically adjust to account for pipe travel time?
The TC that you input is the TC of the drainage area. The TC that Hydraflow calculates gets calculated iteratively, especially if you pick that the method that I discussed, the enhanced modeling method, where it calculates 3 iterations trying to balance the TC with the HGL to get them as accurately balanced as possible. So that calculation adjusts the TC, but the travel time in the pipe, the TC in the pipes is calculated. The TCs I was inputting, those were the TCs I calculated in my case using the FAA method, and that's the TC of the drainage area from the most distant points to that inlet. I hope that answers your question.
Well, this was being recorded. We will